Surge.ai is a very impressive company. I think Edward Chen, the founder, CEO, is one of probably the most successful entrepreneur ever, because with no VC money, a very, very high revenue per employee, you can't argue. I mean, this is just amazing in any which way. So that, having said that, what we want to talk about here is kind of the way we see the world of AI evolving from the context of data. Like we've said many times on this podcast, there are two vectors that will drive intelligence: data and compute. And what's important here is also what we're not saying. For example, algorithmic innovations, mathematics, things like that, physics or whatever. None of that will actually make a big difference in data and compute, other than, of course, maybe a breakthrough in physics like fusion energy could eventually lead to a lot more compute, things like that. But that's second order effects. So what we're trying to do here today is give an overview over how we see the data side of the business, because it's sort of the, maybe the right word would be éminence grise, which is a sort of a French-German word. It's the one thing that matters, and it's the one thing that people rarely actually talk about. Data collection is super important, and I think the reason Edward Chen is so important, is so successful with his business, is because he is solving that problem for a lot of research institutions. If you invest hundreds of millions for employees, ML researchers, if you invest billions in infrastructure, why wouldn't you invest in data also, right? I mean, that's just a logical question. And the answer is you are investing. Maybe not as much as you should, but you also are not going to split pennies here because you want to have the best possible data. And the question comes up naturally is, okay, what is good data? What actually is high quality data? And that in itself could be an AI problem, because it's a very hard to define problem. What is good data? Now, I'm going to give our conclusion and then talk a little bit about it more generally. So the conclusion that we have here is that, it is really not about the data itself. It's about exposure, because the AI that we're envisioning is the AI of experience. So what we really want to do is expose our agents to as many worlds as possible, and then have them learn, and hopefully learn with very simple rules. Rewards enough. The essay by Silver et al. Is sort of the backbone of this thesis. Sutton's continuous learning idea, the oak architecture, is the algorithmic implementation of that. But fundamentally, what we believe is that data collection, data annotation, high quality data, all these things are short-term fixes for a real problem, and that is that intelligence is a highly Kolmogorov complex problem. So in other words, you can't shorten this in some sort of algorithm or something that there's no shortcuts to intelligence. Intelligence means exposure to as many worlds as possible, and then learn to behave in those environments in a way so you can then translate your learnings into achieving goals in actual real world scenarios. That's what intelligence means. Therefore, companies like Surge, as successful as they are, in my opinion, are fixing a problem right now, a shortcut that is anathema to the bitter lesson, because what we're trying to teach the models here is how to think, instead of teaching them to think and then learn. Or in other words, we should be cherishing the intelligence and not knowledge. Now, I understand right now, if I'm an AI lab, if I work for Facebook or XAI, I need to develop a model. And the way this works is I need to beat benchmarks. I get rewarded for beating benchmarks. There's benchmark hacking. And by the way, this is how human society works in general, right? We do benchmark hacking with SATs, and we send our kids to play water polo so they can get into top-notch universities. All of these things are benchmark hacking because they're not really solving problems. Like if my child gets into a top-notch university because she's playing softball and then she can't really do the coursework, what have I really achieved? But that's exactly what we're doing with intelligence right now. Llama 4, I think, is a good example. GPT, whatever the last version is, also very good at benchmarks, not so good at real world, problem solving. So how do we get from benchmark hacking to actual useful intelligence? Surge.ai is a bridge to that. So yes, we can have as high quality as we can. Like we can hire PhDs to teach the models how to think, to teach them how to solve math problems, to teach them how to tackle physics problems. That's okay. I'm not disputing that. Surge.ai is a very successful company, and that's what they do. Scale AI probably is doing the same thing, and there's many other AI companies also. The frontier labs themselves are probably hiring people to do that kind of work. But the solution long term is actually not to look at data. Data is not the problem, but the problem is experience. We have to build experiences. So this is sort of akin to your child. You have two options, right? You can send your child to school and have the child learn how to think, learn how to write, learn how to, X. Or you can have your child exposed to as many worlds as possible. And now imagine if you could clone your child, which is really what AI can do. In other words, you can have many, many worlds, millions of worlds. Your child can be an artist. Your child can be a sports person. Your child can be a criminal I don't care. I mean, like anything. And then you run those simulations, and you just see where she comes out most successful. Define success, of course. Maybe you want your child to be happy, enthusiastic, have a life. Maybe success is just you're on your deathbed and you have a nice smile, and you are surrounded by grandchildren and they are all impressed by you. Or whatever the goal is you're pursuing, you will choose that path that gets you the most reward. So I guess for people in the industry, I guess you're seeing where I'm coming from. I'm a bitter lesson pilled person, so it is about scalar rewards, simple rewards, and lots of exposure into highly complex environments so you can build highly complex intelligence. Now, how does that relate to this problem that Surge is solving, which is data collection? Well, again, I think it's not about data, it's about experiences. Now, that in itself, of course, is data. And you could say at some point, asymptotically, they merge together. What's the difference between exposing a model to many different trajectories? Let's say a robot has many different trajectories in how it walks through a room and cleans the room. And then we could have a human actually annotating the robot and do all of that. Well, the difference, of course, is scale. That's the difference. Because in the end, this whole industry is about scale. And I think we spoke about this yesterday in our episode about the data factory, the way we see AI 3.0. So AI 3.0, which is the business of the future, is a business where the actual business is producing data in a data factory, which then creates environments or produce environments in an environment factory, let's call it that way, that produces tokens, and those tokens teach a model how to solve problems in the real world by pursuing goals and discriminated by a simple reward function. So where does this leave AI? What does that actually mean? Of course, as an AI research lab, so what do you want me to do now? Well, I have billions of dollars, XYZ, you name the name of the company. We all know who they are. Where should I invest my money? Well, one thing, invest in creating these many worlds. That's very important. The other thing is think very hard about the reward function. Reward function design is the new Python or Java or whatever. That is the programming language of the future. how are we, programming an RL agent, programming an agent? I think RL agent also is a legacy word that will go away. There is no other agent than RL agent. So programming the agent will be a reward function design problem, and creating the environments will be the data problem. So what we need is, again, what we're going to see in the future is experience factories, reward function design, and lots of compute, and that will create the kind of intelligence that will bring all these things that we promise ourselves, like, for example, new type of science, chemistry, physics, other solutions to problems that we have right now. I know better traffic systems. Most importantly, in my opinion, very mundane problems like material science problems. How to build better, tiles for the starship so it can deal with the heat changes during flight. How to create better batteries. Those are real problems that can be solved with an agent that is trained appropriately in the context of many environments, simple scalar reward function, and then lots of compute. Thank you.